Problem 5. Two particles move along the x-axis. For t between 0 and 8, the position of particle p at time is given by the formula x of p, and while the velocity of particle q at time t is given by v of q. Particle q is at position x equals 5 at time t equals 0. So there's a couple things I'm going to underline right now. For x, this is the position, so just be careful. And then q, that actually was for p, sorry. And then q, we're given the velocity. So just make sure that you're paying attention to that as you're answering these questions. Okay, for part A, it says, when is particle p moving to the left? So this is particle p right here, and it says when it is moving to the left, so I need to consider the velocity. They give me the position. So the first thing that I need to do for particle p is find its velocity, and I notice that this is an ln, which is like the ln of u, and the derivative of ln u is du over u. So that is what I'm going to do first. So the velocity of particle p is equal to du, the derivative of t squared minus 2t plus 10 is 2t minus 2. And then over u, our u would be t squared minus 2t plus 10. So I found that velocity. If I want to know when it's moving to the left, I am going to find the critical numbers and make a velocity chart. To find critical numbers, I'd set the numerator equal to 0 and then the denominator equal to 0. If I set the numerator equal to 0, I'm going to get t equals 1. If I set the denominator to equal to 0, I actually try to factor it. It won't factor. If you use the quadratic formula, you're going to get a negative underneath the square root. So there are no values. This will not ever equal 0, so because of the quadratic formula. So we don't have to worry about critical numbers in the denominator. So then from here, I'm going to make a velocity chart. So if I make a velocity chart with 1 on it, excuse me, before 1, if I plug in anything before 1, and let's see, if I plug in 0 into the numerator, I'm going to get negative 2. If I plug 0 into the denominator, I'm going to get 10. That gives me a negative value. And then if I plug in, let's say, 2 into the numerator, I'm going to get a positive number. If I plug 2 into the derivative bottom, I'm going to get a positive number. So positive divided by positive is a positive. So that's what my velocity chart looks like for particle p. And then it says, when is particle p moving to the left? It's going to be in this interval right here. Whoops, I forgot to put a 1 on there. So I would say the particle is moving to the left, starting at 0 and going to 1, and I'm going to put a parenthesis at 1 because it is changing signs there. Before 0, it is not changing signs at 0. So that's what it would look like. And my justification would be because the velocity of particle p is negative. Okay, and this problem we were given 2 points. I'd get 1 point for correctly identifying the velocity, and I'd get 1 point for this correct interval. If you had parentheses 0 to 1, they are not going to count it wrong. So as long as you have the interval 0 to 1, you should be fine. Generally, we do get a point for the reasoning, but on this problem, they must not have had enough points to give, so I'm not getting any points for my reasoning this time. Okay, part B, for 0 to 8, find all times t during which the two particles travel in the same direction. So I need to compare the velocity charts, and I'm going to take the velocity from p. I'm just going to rewrite it on here. So that was my velocity chart for p. I now need to find a velocity chart for q, and please notice that q, the velocity started. They gave me the formula for velocity. So I'm going to go ahead to get my critical number. I'm going to take this and set it equal to 0. This will factor t minus 5, t minus 3. So my critical values are going to be 5 and 3. So if I make a velocity chart I'm going to actually write it over here, the velocity for q, my chart's going to have a 3 and a 5 on it. If I pick something before 3, I'm going to get a positive value into the velocity formula. I'm going to, if I put something between 3 and 5, I get a negative value. If I plug something in after 5, I get a positive value. So we would like to know when the particles travel in the same direction. So I'm looking for where does the velocity have the same sign. And let's see, it's going to be before, it can't be before 1, but after 1, somewhere in between 1 and 3, we'll know that the velocities, the particles are going to travel in the same spot. And then again, I notice after 5, and this is everywhere after 1, so between 5 and when we end, which was going to be at 8. Okay, and again, if you did not put brackets, you're going to be okay. And then my reasoning would be, why do those two particles travel in the same direction? It's because V of P and V of Q have the same sign. Okay, so we would get 2 points for this one. I'm going to get 1 point for my answer. So if you have the intervals 1 to 3 and 5 to 8, we'd get a point. And then if I have my correct reasoning that the velocities have the same sign, I would also get a point for that. If you happen to just have these intervals but you did not give an analysis, they would not give you any points at all, so we want to be careful about that. And if I had one of these intervals but I didn't have the other one but I did have the right analysis, I could get one of those 2 points. Okay, part C. Find the acceleration of particle Q at time t equals 2. That's my first question. And then, is the speed of particle Q increasing, decreasing, or neither at time t equals 2? So that's my second question. Okay, so first question, find the acceleration of particle Q at time t equals 2. Well, I know the velocity, so to get the acceleration, I'm just going to be taking the derivative. It's going to be 2t minus 8. And so the acceleration of particle Q at time 2, just plug in 2, and that is going to give me negative 4. So the acceleration of particle Q at time 2 is negative 4. Okay, so that's the first part. Part 2 says, is the speed of particle Q increasing, decreasing, or neither? So I know for this one I need to compare the velocity and the acceleration. So I need to know the velocity of the particle at 2, and then I need to know the acceleration of the particle at 2, which I already know is negative 4. Okay, to get the velocity, I'm going to sneeze just a second. Nope, not yet. Okay. To get the particle, 2, we're going to have 2 squared minus 8 times 2 plus 15. That is going to give me 4 minus 16 plus 15. That's going to give me 3. All right, so I know the velocity of particle Q is positive, the acceleration is negative, which means the speed is decreasing. And I need to say why the speed is decreasing, because the velocity of Q at 2 and the acceleration of Q at 2 are opposite signs. They are working against each other. Okay, this would have been worth 2 points altogether. We're going to get 1 point for finding that acceleration, so we got 1 point over here, and then we are going to get 1 point for saying the speed is decreasing with proper reasoning. Okay, for part D, it says to find the position of particle Q the first time it changes direction. Well, when does it first change direction? If you remember the velocity chart, it looked like this. So it first changes direction at 3. So it wants to find the position of the particle. I could change this question to say at time t equals 3. So if I want to find the position at a certain time, I first of all need to find a formula for position. This is a formula for velocity. So to get from velocity to position, velocity is like miles per hour or something like that. And if I want position, which would just be miles, I'm going to take the integral. So I'm actually going to be taking the integral of t squared minus 8t plus 15. And if I do that, that will give me the position of Q. That will be 1/3 t cubed minus 8, well actually it will be 4t squared plus 15t, and then I can't forget that plus c. So now this is almost my position formula, but I do have a c that I want to find. They did very nicely tell me that at t equals 0, the position is 5. So the position is 5 when t equals 0. And that is going to make c equal 5. So my new position is x of q equals 1/3 t cubed minus 4t squared plus 15t plus 5. And that they did not ask me for the position, they asked me for the position at time t equals 3. So now I am going to plug, I'm going to come up here, I'm going to plug 3 in for everything. And if I do that, my position is going to end up being 23. And please remember, it's a non-calculator problem. If you just wanted to leave your answer right like that, you are going to get the right answer. So my points on that one, I'm going to get 1 point for finding a formula for the position. Okay, I'm going to get 1 point for using my initial condition, and then I'm going to get 1 point for getting that right answer.